Hello and welcome back in episode number 4. As per our ritual, today we are going to recap about the episode number 3 in which we discussed about the land graph. We, me and Rahul both explained land graph very fundamental way on that day. And if by any chance you missed that episode, I definitely encourage you all to go back on that episode and please check that episode first because we have scheduled all podcasts in some logical order. So this today's podcast make more significance or make more meaning to you if you go back to the last episode where we discussed about the land graph. All right, so let's continue for today's podcast. Hello, everyone, and welcome to Demystifying Multi-Agent System. I am Abinash, your guide today to the world of intelligent system.
Hello everyone, I am Rahul. In today's episode, we will explore what multi-agent systems are. We'll discuss their design, architecture, and explain how these technologies work in real-life scenarios. So, let's begin.
Yes, so in our first segment, we will discuss about the understanding of multi-agent system. Let's start with the basics. So what exactly are multi-agent system? In simple words, these systems are made up of many small programs or agents that works together to solve larger complex problems. Think of it as the team of experts where each member has a specific task. When each expert does what they do best, the overall system works more efficiently.
That's right. So, we can imagine this like a cricket team. So, every player is having a role. Someone is a bowler, an all-rounder, someone has its speciality. At one moment of time, one would be executing certain tasks and they would be doing some kind of coordination to win the game. So
Exactly.
similarly,
Yeah. Please go ahead.
multi-agent systems, they also rely on several agents who would be communicating and collaborating. So to add on, the LLM systems or the routine generative AI systems, they are actually reactive in system. So you are having an LLM, you provide a prompt, till you have provided the prompt, nothing would happen.
Yes.
So the LLM system gets using a prompt and then it churns out something, it generates something.
Yes.
So you put an input as a prompt, you trigger it, it will give you some output and the story ends there. How you use this generated content or you issue a fresh prompt is up to you.
Yes.
But in contrast, the agent AI systems, the agentic models, they are, although they need to be triggered by the initial prompt, but post that they are pretty independent.
Yes.
So they can use the generated output from one agent, use these actions, coordinate it, find out what would be a relevant agent, figure it out, pass it as a new prompt to the next agent, and get the entire work done using a chain of communication and collaboration, which we will be discussing in the as we progress.
Yes. Yeah. So this approach is not only flexible, as you explained, but also scalable. Instead of one large program trying to manage everything, dividing in this scenario, we are dividing the work among different agents, help to manage complexity and adapts to change more easily. So you in totality perform better than a single LLM application, right?
Right. It's actually a very clever solution. And actually, this is the solution. In the world, you do not have a reactive approach as such. The real world is having a series of tasks, and you would not know what task needs to be triggered when. You cannot have a very simple routine. Somebody gives a prompt and somebody replies back. You have to manage this entire, you have to orchestrate this entire stuff.
Exactly.
You cannot have a guitar and you can plug one string and the music is done. That it doesn't happen like that.
Yes.
You need to have a guitar, you need to have a conductor, you need to have a violin, you need to have tabla, and you need to have a drum, and you need to have n number of musical instruments and a singer. And
Yes.
that is where the music will go.
Yes.
Not that you can have one stick and you do a dang and it's done.
Yes.
So
yeah, definitely, Rahul. So
real world actually.
Yeah. So in real world, as you explained, even in just take one example as a software projects, in that software project also we can definitely have one project manager, then there is a one senior engineer whose role is architecting the system, then there are some more engineers who are probably considered as an individual contributor in the project, and all together these all members are primarily working for a single project to accomplish the overall project execution or project task, right? That is how our software team is progressing, right. And this is how our multi-agent system is working in this multi-agent systems, right?
Yeah.
So yes. So let's move to the segment 2, where we will discuss some of the key architectural patterns useful especially inside the multi-agent system. Now that we understand, Rahul. Yeah, go ahead, Rahul.
Yeah, so just like you have given some examples, so the kind of examples we have discussed, these are actually very, very typical of the different kind of architectures that are prevalent.
Yes.
So right.
So now that we understand what multi-agent systems are, let's talk about different architectural patterns used to build them. There are a few common modern that designers and developers or senior engineer in the team must rely on. The first architectural pattern, which is called network architecture pattern. And
so in a network architecture, it is the simplest of the architecture. Every agent communicates with every other agent. So it is like the loosest possible, the first group together. It is like friends meeting in a coffee house.
Yes.
Everybody can talk to everybody else. The structure is very flexible. As everybody can figure it out. The biggest problem here is that since there is no command, no structure, there would be hell lot of messages that would be exchanged.
Yes.
So there is a risk of communication overload. Otherwise, it is the simplest architecture. The first evolution would happen from a typical LLM model. When you move it to an agentic ecosystem, this would be the first and the simplest architecture that would be there.
Yes.
Still useful, but
of this approach lies in its flexibility, because it is free for all. Anybody can discuss with anybody. There is no restriction at all. So that's why it is called flexible approach to start this multi-agent system. But but coordination is key here to avoid the misunderstanding or delayed response when the system becomes too busy. Because everybody is
problem of democracy, too much democracy.
Yes, exactly. Yeah. So moving on, actually, Rahul mentioned exactly the same word, which I also thinking that this is the actual problem of democracy. When everybody start their own discussion with others, and that is also very open in nature, no restriction, no filter at all. So that will sometimes create a chaos in the system itself, right?
Right. So let's move to dictatorial pattern.
Yes. Yes, please go ahead.
So a little bit of dictatorial. So from democracy, we are moving to a little bit of dictatorship, which is supervisor architecture.
Exactly. Yes.
So here what happens is the initial prompt is sent to one central agent. This central agent is like this agent is in role of a manager. This agent, what it will be doing is it will be assigning the task to, it is kind of a triager. So it will take the prompt, it will find out what out of this task, what would be my task list, what will be done to by whom, and getting back the response, collating it, and then providing the serving to the caller is the responsibility of supervisor. So this is the supervisor architecture. It's like a project manager in a office setting.
Yes. So we can say that, like as I given the one example, like in the software project also, we have one project manager, and then there are many other person who are working with project manager, and project manager primary responsibility is to divide the task among the other members of the team, right? The same way supervisor architecture is also supposed to do here. All right, so this approach brings clear direction and order. This is one advancement over the network architecture you can visualize here, that in this case, you have a clear direction and order of the processing, right? The supervisor ensure that tasks are allocated properly and that everyone knows their part in the process. Now, next architecture in little bit more advanced to supervisor architecture, that is called supervisor tool calling architecture.
So again, it's the same story. People are not happy with the manager because the manager does not do anything. He just takes the response and allocates it to random people.
Yes.
So here the story is little bit advanced. Here the manager is very technical. He does some kind of tool calling.
Yes.
So before assigning the task, he doesn't do a random, assignment. What it is capable of doing is that it takes the prompt, it does some kind of processing, takes out certain information from X number of places, and this information processing is also a part of it. It could be another agent also, but
yes.
So it calls up multiple tools. So for an example, let's say that if I am getting some kind of video, from extracting certain information, getting the data, hitting the database, calling some APIs or some other kind of tool to process, getting the information, collating it, and then passing it on to the relevant agent. This would be a tool calling architecture.
Yes.
We can call it as one can say it is very similar to supervisor architecture, but the only difference is supervisor architecture, the vanilla supervisor architecture is kind of a thin supervisor.
Yes.
Here the responsibilities of supervisor are little more advanced than the routine, the vanilla supervisor architecture. So he has access to certain tools and specialized agents to tackle the particular problems. So the agent's intelligence is relatively diminished. Lot of heavy lifting is done at the supervisor end itself because he has access to the tool. He can call multiple tools.
Yes.
So non-agentic models can be called up by the supervisor rather than passing it on to and getting it done through the downstream agents. So it's like a dispatcher who doubles down as a quartermaster in physical world scenario. That he is not only the manager, he is also the Q of James Bond. So,
right.
So he brings the guns and all, and he says, "Okay, take this Walther PPK to when you go on a mission."
Right. So I mean, as per your analysis only, I can, if I want to add one more point, then we can say that this is an additional capability of our supervisor, like a manager, which can directly dispatch the right agent to execute that task. That is the extra capability over the supervisor architecture, right?
Yeah, perfect.
Yeah. So this model adds another level of efficiency, as Rahul explained, by dynamically deciding which agent is best for each task. It adapts quickly to changing conditions, ensuring a smoother operations. So up till now, we have covered network architecture, supervisor architecture, and supervisor architecture calls tools, right? This is the three architecture we discussed. Now the next architecture, which is again in the similar line, it is called hierarchical architecture.
Right. So this is the next level.
Yes.
Logically, if we are thinking we are living in a chaos, then we have decided that there would be one person who will be managing it all. But just like we have discussed that this actually reflects the real world scenario. So it is a very similar kind of thing. You are having a very chaotic environment, then you are having a very small team, which is managed by one guy who has control over everything. But the real world is not like this. The real world is very hierarchical. If you take a typical office environment, it would be having different departments and that kind of stuff. So a logical extension of having another type of architecture would be a hierarchical architecture. So this architecture features multiple level of supervisions.
Yes.
So it would be very, very similar to an organizational chart. So there would be supervisor at different levels. The top supervisor can call and devolve its responsibilities to the downstream supervisor, who would again have a similar kind of structure as another hierarchy, or just the vanilla supervisor model or supervisor role calling model kind of structure. So it would be like higher management to the middle management to the lower management kind of structure, and this is how it would go. The only visible problem logically and intuitively would be that it would be complex.
Yes, it becomes complex.
And that is the strength also, that if be complex, hierarchical model has to be put in place, or the supervisor model or other models, they will converge into being an hierarchical model eventually as the complexity grows, to ease up the complexity.
Yes, in fact, I would like to mention here that this hierarchical architecture is the kind of multi-layer supervisor architecture, right? So if you can consider one layer as a supervisor architecture, if you put all these layers to layer in supervisor architecture, that becomes a hierarchical architecture. I think this makes sense.
If I can give an example, a similar example. So there are 2 or 3 friends who come together to form a startup. That would be network architecture.
Yes.
Eventually, the supervisor or the remaining founder, he becomes the father figure of that startup. And there are some freshers or interns he has hired. So that becomes a supervisor architecture. He coordinates with multiple third parties. So it is supervisor role calling. So whatever he cannot do, he actually outsources or does a partnership with other players. So it is supervisor role calling, and then his startup grows up. It becomes a big organization. He has to create multiple departments, and it is a full-fledged company. Hierarchical architecture.
Yes. Very true. This is the net analysis of all these architecture, which up till now we have learned, I think. All right. So moving on. So we have covered the 4 architectural pattern until now, and next agenda for our discussion is to understand design patterns for collaboration, because once you fix your architecture pattern, now it's time to think about how your component and the overall collaboration of components is going to happen within the architectural pattern. So in the next segment, we will discuss design patterns for collaboration. Once the architecture is in place, as I mentioned, the next step is ensuring agents work together efficiently, right? There are several design patterns that promote collaboration among agents. The first design pattern is collaborative task solving, and Rahul will help us to understand this design pattern.
Yeah, so again here also there is a similar kind of thought process. Intuitively, what would be the first design pattern?
Yes.
It would be collaborative task solving.
Yes, yes.
That would be the first one. So
Yes.
obviously it is the first one, it would be most popular one. So the collaborative task solving is very simple. A large task is there, it needs to be broken down into smaller manageable pieces. The different agents have different capabilities. Each agent tackles a part of problem, and the result is actually combined together to form the complete solution.
Yes.
So it is like doing a puzzle.
Yes.
A bigger problem is split into multiple parts. They are solved independently and then joined together. So
yes, so
each piece is like joined together to form a final picture. So
exactly. Yes, Rahul. This method leverages the strengths of different agents, ensuring that everyone's expertise is used and the overall problem is solved more effectively. If you are a developer experience, you have seen that many programming problem is solved by using this concept. Like you are dividing your problems into the sub-problems and then solving each sub-problems separately and then finally combining these problems, a solution to these sub-problems, and achieving the final solution. All right, so let's move to the next design pattern, which is called team organization.
Yeah, so again, the logical progression from the collaborative task solving approach would be creating a team.
Yes.
So here the agents are grouped into teams, and the teams would have specific subtasks which they will combine at their end. So it is very similar to the hierarchical. If you are having a hierarchical architecture, the team organization would be the default task solving design pattern.
Yes.
So it is very similar to how a team in a company can, and just like you are having team, and within the team you can switch the agents. Just like in your team, you can switch the members and replace it with a new member or add new members or subtract and that kind of stuff. So very similar to that here also, the design pattern is having a pluggable agent. You are having, you have a project need. The need gets served by a team. The team is having multiple agents into it. The agents are pluggable. They can come and go. Depending on. So this would be a very typical of team organization design pattern.
Yes, exactly, Rahul. So it adds basically a flexibility to the system. Somehow now you are making your team structure in such a way that members can be replaceable. If one member is not available or somehow is not assigned to particular task, then in that case also some other member can take that task and resolve that task or take up that task for their action. So that way, we are adding some flexibility to the system, right? Now let's understand new challenge arise, because in this system, again, a new challenge arise. Teams can be reformed quickly to bring in the right mix of skills and knowledge, right? So next design pattern is collaborative loops.
Logical extension.
Yes.
If you know what you need to do, you can have a team.
Yes.
But real world is not like that. So if you want to build let's say a table or a chair, you know that you would be using wood, you would be using blah blah blah, and you would need a carpenter and X number of assistants, and you start building the wooden table,
Table, right?
right? But let's say that the the needs are not that way simple in the real world. The need is often dependent on the feedback of what has been done so far. So, what kind of agent, what kind of capabilities, what kind of uh, requirements would evolve? That would depend on the feedback from the action itself. So, the team which was having defined functions, now it moves into logically, that would be just simple logical extension. The next type of design pattern is going to be collaborative loop. You are having an agent, the agent continuously shares feedback, it does some action. Based on that action, the calling to the next agent, or the output or the prompts to the next agent or the action series, they are going to change. They are going to refine. So it's like a brainstorming session where the ideas are continuously getting improved, or something like you go to certain let's say to a design house, you say you show me this, and then you say, can you add some lighting there, can you do this, can you do that? So let's say if you are going for an interior designing kind of stuff, when the interior designer goes in, he actually doesn't know. He knows that he will do something like this. But when he goes there, there would be n number of requirements which will keep on emerging. Everything is doable by him, but it is not structured in that way. That these are the 5 things that needs to be done. Yes. It would be, he will go there, he will find out something, and then there would be a feedback. Okay, fine, there is some space here. Can you add something here? So
yes.
The real world parallel would be like things would evolve as you discuss, as the agent progress, the new situation will arise. So that is collaborating.
Yes. So in one another example we can take here, that we can build one project, software project. Just imagine in this way, and we have a multiple component part of this software project. So, and the structure of software project in such a way that their interface between the component interaction is fixed, but the component itself can be refined multiple times. They can independently work, right? These components can be improved independently without impacting the overall structure. So that will help us to achieve each component of their maximum improvement, right? They can independently improve their own component. So that is what collaborative loops will do for us, I believe, right, Rahul?
Right.
So yeah, so let's continue then. These loops ensure that the final result is well refined, and as the agent learn and adjust continuously during the process. The next segment.
So this is the nearest to the real world.
Yes, exactly.
So the previous approaches, the previous patterns, they are like the simplistic ones, starting points. But as we progress towards more and more real world problems, this would be the situation. Let's say there is a chatbot, what you are building up.
Yes.
You call up a bank. If you exactly know what I need to do, then yeah, you can give some free text. You can say, I want to do this. The chatbot is going to ask you a number of questions, 2, 3, 4 information. You provide all this information. You say, okay, fine, and the work is done, or the information is shared. But the real world is not more like that. The real world is more where you give some kind of, you also have a lack of information. That lack of information is not fulfilled. The thing keeps on evolving, and that is where the team kind of pattern comes in. now if the situation itself is changed, that
Yes.
is where the for example, let's say if you have gone to apply for a loan, okay, or let's say if you have gone for to apply for a credit card and the agent is capable of selling you a loan, or the agent has sold you an insurance. So these things are evolved.
Yes,
The
yes, yes.
person, you give information, I have this credit requirement, there's best, blah, 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 blah. And from your talk, the agent is able to figure out that this person can be sold an insurance. So this is actually the collaborative loop.
Very good example,
Where
in
you,
fact.
right?
Yes, yes, yes.
So real world parallels to
Yeah.
have a, uh,
Yes,
to
yes.
remember.
Exactly. That is what collaborative loop will do for in this case also. This is very close to real world example. Right? All right. So moving on. So in the until now we have covered architectural pattern. We have covered design pattern, meaning we discussed about the overall structure. Then we also discussed about how these design pattern can be used inside the components to build a very well structured component. Right. Now, next thing is that how agent can assume their roles, and that role is going to explain how multi-agent system is working. So in the next segment, we will discuss about the roles in multi-agent system. Stay tuned. All right, welcome back. So we can start now again the segment 4. And here we are going to discuss about the roles in a multi-agent system.
Yeah. So just like we are having multiple questions which start with what, why, who, how, and blah, blah, blah. So we are having a what, which is the architecture. We are having how, the design patterns. Now there is the next crooked question, who? So who is the role? So if you are
Exactly.
having a system, you need to have some kind of role. Now, the first role that would be there in any kind of multi-agentic AI system.
Yes.
Again, if we logically think, if one has to create a new system like this, it would be the manager's role. Because you need to have a supervision, some kind of triaging that needs to be there. So the first role that would logically come to mind would be manager's role. So here this manager agent, the manager role, when it is assigned to an agent,
Yes.
this agent is responsible for the planning, task and assignment, and overall coordination.
Yes.
So this role is very similar to the typical definition of manager. It would be a project leader who ensures that every part of the system works together seamlessly. So that's his work.
Yes. So you can also say that if the manager role is performed well, the system benefits from clear guidance and structure which leads to more efficient operations. Am I right, Rahul?
Correct, correct. Yeah, precisely. So again, going by the same logical thinking, if we churn our logical thinking forward, what would be the next role? The specialist.
Yes.
An agent who is good at its work, but doesn't want to do all this coordination, planning, and all. He is a techie. Give him work, take back the work. Period. So he's the specialist.
Yes.
This is the specific agent who would have certain expertise in certain area. So, for example, there is uh, uh, a typical project where you are doing some kind of financial analysis, for example.
Yes.
So the manager's responsibility would be to figure out which all data sources the data would be pulled, from where the real-time data would be uploaded, and blah, blah, blah. And all these subparts would be either done by the manager or it would be given to some other agent. Now,
Yes.
this specialist would be someone like a data analysis specialist. You give him data or you give him the data source, give this agent the data source, he will process all sorts of, prepare an analysis and would send it back. This information goes to another agent who plugs all of this into a beautiful PPT, brings it back. So these are the specialists. I give only the text, plain text. This agent converts it into a fancy PPT.
Yes.
Maybe add some music, background music and all, and return it back to me. Very typical of a routine office environment. There would be some person who would be very good with data, but the moment you ask him to make a PPT, he will go bonkers.
Yes, yes.
So there would be some person, give him this thing and he will just polish the PPT to a next level.
Yes, typical corporate
and the
environment.
overall responsibility.
Yes.
Very, very, very typical corporate environment. It's a replica.
Yes.
And there would be a manager who would know that this guy will do this work very good, that guy will do that work very good. If you flip the word, I mean, obviously the flipping is not possible because it's an automated system. But that's the real life replication. So in this context, the task or the system as a whole becomes much more effective.
Yes.
Because the individual agent knows its work best.
Yes.
So that is
the
specialist role comes in.
Yes. So specialists bring deep expertise to their task, using their unique skills, helps improve overall performance and makes the system more resilient to the challenges, right? So next role which we are going to discuss is the coordination role, because we already discussed the manager role, we already discussed the individual specialist role. Now the time is to coordinate these specialist roles.
That's the only role which is left. Logically thinking, that would be the case. There would be a manager, there would be specialists who are good with their work. So what's left with? There would be a coordinator.
Yes.
So if we logically move forward and think in that way, they would be, these agents are like a glue which hold different parts of the system together. So they are the ones who are responsible for ensuring smooth communication between teams, resolving gaps in coordination.
Yes.
So that's the logically that is the role left.
Yes. So when coordination is strong, the system rules more fluid, as all agents remain aligned and aware of each other's progress. So that will make a successful team output on the paper and as actual working environment. And you can, like as Rahul mentioned already, that this is typical corporate environment is also working in the same way.
So when it comes to the agentic systems, the thing is that these ecosystem is actually fast evolving. So and these are changing very, very frequently and getting updated, and they are huge systems. They are not something which is very small. So and costly as well.
Yes.
So obviously you would want to have a huge amount of flexibility, and at the same time you need to have a very, very robust approach. Because what we are dealing here is that we are not constrained. When it comes to a typical web page, you would be having a drop down. You cannot select anything else. Here what is happening is that something is coming in free text and you have to make meaning out of it. And if you make an absurd meaning out of it, you might take a decision which will be wrong, and not only wrong, it would be percolated down to other systems where again there is no human intervention. So one mistake at one end is going to have a disaster by the time it goes out. So you need to have certain kind of autonomy in the system so that the robustness is intact, and at the same time you should have huge amount of flexibility. So again, logically thinking, it would be design time autonomy, which means that when you are creating this design, creating this system where the agents would fit in where, you can have this design time autonomy, that you can have that this kind of agent is going to have this kind of LLM backend and this kind of interaction. And on these patterns, the supervisor is going to triage it to these agents suitably. So it means that you can modify or update part of the systems without disturbing the whole setup. You can have this replacement, that one particular agent gets replaced or bypassed, so that the other agent with similar capability, enhanced capability, can be plugged in.
Yes, yes.
At design time.
Yes, yes.
So and this does not require any kind of shutdown.
Yes, that is a very important point you mentioned at last. This is really a good observation. I mean, as per behavior point of view, if we are providing design time autonomy, this makes more significant to the system. So this type of autonomy ensure that the system can evolve with minimal disruption to its operation. So as design time autonomy explained, that we can modify a part of the complete ecosystem independent to without disturbing the whole system, as already explained by Rahul. So next segment of autonomy is called runtime autonomy.
So again, logically, it would be that since the system, the first case is that you are having it, the components are changed at design level. Here, the thing is that the components, they can be changed, they can be replaced, or they can have a new path at the runtime. So during runtime, based on the feedback of a particular agent, a new path can be chosen.
Yes.
In the runtime. Yes. If something goes wrong, the system automatically adjusts, evolves to keep the functioning smoothly without compromising the robustness or the flexibility of the system. So this is the okay. So I have an example again to differentiate between the two. Let us say you are having an automatic driving vehicle, which is having both cameras as well as a lidar sensor. Okay.
Yeah.
Now design time autonomy is where you are having both these sensors. You are having camera, and based on camera feedback, you are doing some kind of analysis and running the car. Now design time autonomy is where you decide whether you are going to use camera or you are going to use lidar sensors. Runtime is that you are having both the sensors. The design thing is that you are using camera, but because of some reason, the system anticipates that let's say that there is a lot of fog. And it evolves at the runtime that because of fog, my camera feed is not all that efficient.
Exactly.
So to assess the distance analysis, I am switching to LiDAR at the runtime. Nobody has told me to do. But
exactly.
Since my feedback from both the things are not matching up, I take a decision. So that's the typical way this is going to function.
Yes, very true.
I just
very
from
true.
your example, I picked up
exactly. Your example is very accurately explained. I think audience can understand now better. So the next, so in sequence of this, first we have a design time autonomy, then we have a runtime autonomy. Now next again comes to the composition autonomy. So
Yeah, so again, the composition autonomy would allow different agents to work together on a common task while still operating independently.
yes, yes,
So
yes.
the agents have their own capability. They actually work independently, but they would be able to do a collaboration based on well-defined interfaces. If this happens, this agent is going to so a logical extension again.
Yes, yes, yes.
So the
Exactly.
other two are actually little hard-coded kind of stuff. This composition autonomy is about independent ones coming together and achieving something more than.
Yeah, so like if you recap little bit on design pattern or even the architecture pattern, most of the cases we have divided the complete structure in three different parts. Like one part which is deciding the structure, another part which is deciding the speciality of each individual, and the third part which is collaboration, like how to coordinate among these individuals to make a complete goal to be solved or successfully executed by the overall system. So in this segment, as you explained composition autonomy, it means that even when the working as a team, each agent retain its strength. I mean to say that even if all agents are working in a team, doesn't mean they can forget about their specialty. They are always doing their own, playing with their own strengths and ensuring that the overall performance is optimized. That is what we are doing inside the composition autonomy. So until now, if I recap overall discussion progress, we started with the architectural pattern, then we come to the design pattern, then we discussed about the roles of agents, and then
Right.
after that we discussed about the service autonomy.
Correct.
So in the next segment we will discuss about the communication and coordination. So communication is the backbone of any multi-agent system, because until now what we discussed mostly about the agents functionality or how agents can behave, what are their roles, but we have not discussed how efficiently we can make communication between the agents so that this will give you the maximum output, like efficient output of the system. So in this segment, we are going to discuss about that only. So communication is the, as I mentioned, communication is the backbone of any multi-agent system. Without clear communication, even the best design system can fail. As Rahul mentioned, I think in some little back while, he mentioned that if you confuse agents in their work, then even the smart agent cannot perform what he or she supposed to perform. That happens because if, just imagine one example, like your supervisor is giving the instruction, but that instruction is not clear to you. Then what you will do? Without understanding that instruction, you try to perform some task, which probably sometime may hit what the supervisor is expecting, or sometime maybe this is not as per the requirement set by the supervisor. So, and that why it happens because of lack of good communication or clear communication.
Yeah, so logically, again, if we are having agents, the first architectural pattern,
Yes.
the logical outcome of the logical organization for the architectural pattern would be self-organization.
Yes. Yes.
So the self-organization is where the agents, they organize themselves without having any central manager or central authority, which would be giving direct instructions to them.
Yes, yes, yes.
So a real world example would be something like how people arrange themselves in a bus stop, or in a loose environment where uh, people arrange themselves for example, if it is a startup, people will coordinate amongst themselves, find out the most optimal time for a meeting or that kind of stuff, so that everything runs very smoothly.
Yes. So, in simple term, if I would like to mention that this pattern encourages flexibility and quick adoption as agents adjust to change in their environment independently. I mean, you are not guided by your supervisor all the time. You have your own intelligence, so that according to the context surrounding you, you are adjusting your behavior, your outcome, right? So that is what I believe that this means, like self-organization means to us. We are working in the communication in multi-agent system where our direction must be by two-way, right?
Correct.
If you have only one-way direction, you cannot survive in the like multi-agent system kind of environment. So now Rahul can explain us what exactly bi-directional communication is and how it is helping us to achieve better result in case of multi-agent system.
Yeah, so in the previous podcast where we discussed about line graph,
Yes.
so there we had explained the limitations of the directed acyclic graph.
Yes.
So when
Yes.
we know our steps very well, then we never have to come back to the previous step. If I know my task very well, if I'm doing something which I have done it routinely over a period of time, I know the rules, I know the outcomes, I know all the probable scenarios. Unidirectional communication is the best communication.
Yes. Yes.
I give an order, you run.
But assuming that there is no improvement is required in that scenario.
No improvement is required, and it would be disastrous if my instruction, if the ground situation is different from my instruction.
Yes.
Right. So I tell my agents, you run, and the agent happens to be a fish, you are in trouble. There is no water.
Yes.
So, so the bidirectional communication is where the message is going to flow both ways. Obviously, you should be able to take your control from the output of one agent to a previous point. It cannot be a directed acyclic graph where you are having one direction of control flow. The control can actually loop back. It can come back to some point, random point, by using a loop callback function. So in place of a one-way broadcast, the agents, they provide feedback to one another, which leads to a better decision making and continuous improvement. And this is of utmost important because the agentic models, the agentic AI is actually trying to mimic the real world of how humans behave.
Yes, exactly.
The ultimate objective of this entire system is to mimic human.
Correct.
So it has to be bidirectional.
Yes,
if it is not bidirectional, if the situation changes, even in an office environment, one person keeps on giving instruction, we do the junior ones, they will keep on following the instruction. But if something is very, very off, the junior also calls back, this is something which is, I don't think it is very right.
Yes.
Even if he is not asked for an opinion, the person comes and says, oh, this is something off. Is it right? Similar kind of situation. There might be in 1,000 runs, maybe it would be a singular kind of communication, but it is important to have a loopback capability.
You are right. You are rightly said that in real world environment, 80% of chance is the two-way communication is most suitable for that scenario, right? 20% cases might be straightforward, which can be solved by single direction communication.
So even if there is a one-way communication, the capability to have two-way communication is important.
Yes.
The capability should be there.
Yeah. So yes, you're right. You're right. Even though two-way communication is there, that can be customized as a one-way communication. But one-way
Correct.
communication cannot be made two-way
Cannot be done.
communication. Yeah.
Right.
Right. All right, Rahul. Thank you for explaining this. And so this two-way dialogue is critical for the system ability to learn and improve over time, which you already explained in LangGraph very theoretically and fundamentally. So moving on, the next collaboration, which is again in the flow only, as multiple times Rahul mentioned, that we are today moving in a very logical way. So another collaboration is human agent collaboration.
Yeah, because agents are not that intelligent. So, or we really do
Or
not know whether they are so intelligent.
yeah, or otherwise you can say that human has a innovation capability. So human
Right.
must be inside the system. Then only we can integrate with the efficient system as a innovation plus in. Yeah. So go ahead,
Correct.
Rahul. Yeah.
So here the thing is that, so there are two problems. One is
Hmm.
that the agent might not be as intelligent as human.
Yes.
There might be some places where the human creativity or critical thinking is required.
Hmm.
So one area is where we know that the agent does not have this capability,
Hmm.
right?
Exactly.
The other
Yes.
aspect is where we do not know whether the agent is having that capability or not.
Hmm.
So there is a chance that if we let the agent do its own function without any human intervention, the
Hmm.
agent might go off and we would not even know about it.
Yes. You're right.
So it is important that we do one area where we definitely know here the agent will stop, human will take over, human will do till here and then pass it on to an agent. So we need to have a window where human comes in. The
Hmm.
other area is where, despite, since we do not know the agent, so a human enters in, takes the control, lets the agent function, but validates whether the agent is doing it right or wrong. So
Hmm.
both these
Exactly.
capabilities require human agent collaboration. So
Yes.
to give an example, it would be something like, the first case example would be that let's say there is a chatbot where I'm interacting with the chatbot to purchase something.
Hmm.
And after a while, my requirements are not very clear to the agent.
Hmm.
Agent finds that it suggests me one product. I say, no, give me something else. Then I give some kind of vague answer. The
Hmm.
agent gets, so after a while, agent finds that the same product is being told to this person multiple
Hmm.
times.
Hmm. Correct.
Now it is time that I pass it on to a human because he is beyond my capability. One
Hmm.
area.
Yes.
Even this pattern can be visualized by the human to assess whether this person is himself very confused or an inebriated state or whatever,
Hmm.
or uh, he needs some kind of human intervention to enhance the quality of discussion. The
Yes.
other area could be that after a while, this is the place from where I have to take certain kind of approvals. Till I take the,
Hmm.
cannot move forward. So
Hmm.
a very typical example could be that let's say I prepare a report based on multiple data. I
Hmm.
get this report, but then the report cannot be finalized till it
Hmm.
goes to the human eye.
Hmm.
Till I show it to the interested parties. I send a copy to everyone. They agree, and then it moves forward. So
Yes. Yes.
these things
Yeah.
require some human in the middle kind of state. So that
Human
is
in yeah. Very true. Very true. I think your example is very true. Like anywhere human required in the loop, which improve the overall ecosystem, then definitely human in the loop is the required thing. And if we put it, probably it will improve our overall response to the system, right? So when human and agents work together, the system benefits from both innovation and efficiency, which is essential in today's fast changing world. Now, moving on to our next segment where we are discussing real life application and frameworks. And this is why I initiated our podcast and by saying that you audience must go before this watching this episode. It is better to go first watch the last episode, which is LangGraph, because LangGraph is a framework only, which is multi-agent framework. You can consider it as a. There are other framework also available like QAI framework, AutoGen framework. The similar way, LangGraph is also a multi-agent framework only. So that's why I mentioned if you go for it, go. I mean, so if you want to see that LangGraph, I definitely going to put the link of that episode in video description. Please go and watch it.
So these frameworks, they help to automatically assign tasks, monitor performance, even optimize the process over a period of time. And
Yes.
all these functions are the ones which you anyway would be implementing.
Mm.
So let's say if I'm implementing an agentic framework, what I will do is that I will write some sort of way, some sort of algorithm to assign tasks. And unless and until I do a performance monitoring, I cannot have a production level environment.
Yes.
So I will implement something of that sort. I will even optimize the process over a period of time. And to optimize, I need to have a performance measurement.
Mm.
So these framework make my life easy.
Yes, yes.
And by using these tools, the business can handle complex problems easily, and they can ensure smooth day-to-day operations. So
Yes.
that's the advantage of using these frameworks.
Yes, yeah, correct, Rahul. If I have to put one example here, in industries like finance and logistics, these systems enable quicker decision making, right, and improved accuracy. This is why these frameworks are very important. And also other point which Rahul mentioned already, which is also have very significant stake here, is that anything you are building, if it is production ready, and there are criteria for making any application production ready. So either you make yourself to this application as a production ready, in that maybe you need lots of effort, or otherwise other route is to use some framework which is already production grade and use that framework to accomplish your business use case. Right, Rahul?
Right. Why reinvent the wheel?
Yeah, correct. So these are the things which makes framework
open source and freely available.
yes. So yeah, you are right, Rahul. So I think this is the real world example, but of course it is not the only few cases we have mentioned here. You definitely go and explore more cases, put it if you want. If you find any good example which you want to share with us, please put it in the comments so that we also go through, and then we will respond with the relevant analysis or explanation for that use case. If you are interested to interact in that way, that is really great. So in the next segment, me and Rahul try to give some question answer to make it interactive discussion.
So to keep the this segment smaller and not to admit too many questions, and also to keep the as the saying goes, eat your own dog food. So what I did was that I took all the questions which were called, and I prompted the my LLM engine to pick out two representative questions out of it.
Yes.
So we will be discussing only two out of them. It is possible that I have missed out some very smart questions, or the system has missed out very smart questions out of this chunk of questions.
Yes.
But I will do a human intervention and try to figure out if we have if the agentic system has pulled out the right questions or not. Given I'm assuming that it would have picked up the representative questions, because in majority of the cases, if we are having a set of audience, they will have very similar kind of questions. Only a few are there which vary. So let's take a few these two common questions which I have pulled. If there is any other question, we will add it later. If other audience, if they are having more questions, they can always post it on in the comment section, and we'll try to answer them.
Yeah.
So one question which came out to, which was reported to be the first one, the top question from as per our
LLM, LLM agent. Yeah.
LLM,
Yeah.
Llama.
Yeah.
It was, how can these systems scale in real world applications? So
Yeah.
these agentic models, the person wanted to ask how can these systems, the scalability in a real world scenario, because the backends are very heavy.
Yeah. Yeah.
So do they have the capability to scale in a real world application
Yeah,
scenario?
yeah, yeah. So I must admit that this question is really a good question, actually. The answer lies
Hmm.
in good planning and a well-designed architecture, as we are discussing today about more or less architecture and design and planning. So the answer to this question is very simple. They have to do two major things. One is good planning of overall uh, application or whatever the scenario they are they have use case. So for that use case, they have to plan well about the overall multi-agent system. So first thing is that, and then another thing is how well you are selecting the design and architecture, because scalability is primarily depends on how good is your architecture, how good is your design selection. If your design selection is right, probably you can scale that system without any problem. But if your design selection is not right, probably you could not able to scale as per your requirement. So that's why
Right.
these two factors is very important. And when the system communication and coordination are effective, and that is possible if you do these two factors on the point, then only you can think about the system which is communication and coordination effective, right? So at the end we can summarize it like that. You need to be a very good plan, you need to be well architecture selection, and then you need to be a well communication structure. So all these three if you will do, probably scalability is not any problem after that.
Right. And the next question, it's actually the obvious follow-up to it.
Mm,
They are these systems reliable for everyday tasks?
exactly,
So
this is for the
scalable, reliable.
yes, yes,
So
yes,
in my experience, the again it's the same story. The reliability also depends on systems design, since it is a loose architecture.
yes,
So
yes.
knowing the tool itself is not enough.
Mm,
Just that you have picked up LangGraph, it is not going to solve your problem. You need to have, so that is where this podcast becomes important, that you know about the architecture, need to know the design patterns, put
mm,
them into use in any of the tools, whether it is LangGraph or any other.
mm,
And only then you can have a robust design time and runtime autonomy.
mm.
The system can handle the fluctuation, and it can operate smoothly under stress. So
Yeah, Rahul. So
it's around
exactly,
there.
this is what I also wanted to add here, that we already discussed one segment which is called service autonomy, and in that segment we already discussed that how your selection of design time autonomy, runtime autonomy help you to make the system which is more reliable, right? So, and that is what you explained here with in this segment. So I think this is exactly the answer of our question, right? So
Right.
yeah,
So
so
if there are any more questions
mm,
by any audience, so please feel free to drop in. We will try to reply back on the comment section.
mm,
And so that brings us to near close of this podcast.
yes,
So
yes,
as we wrap up today's episode, the audience have to remember that multi-agent system, they are all about teamwork. Being
exactly,
a
exactly.
replica of the real world, it is all
Mm,
about teamwork. Each agent, it brings its skill, and when they work together in collaboration, they solve the problem that a
mm,
single agent So in that case, it would not be an agent, it would be a program. It would get, it will give an output, it would be a reactive system. So when these agents come together, bringing their skills and working in collaboration and in coordination, then it becomes a proactive system. It gets a trigger, it gives a final output based on whatever path it has to take.
Yes, yes,
So
yes.
that is the nutshell of whatever we have discussed.
Yeah, Rahul. This is really exactly how multi-agent system can be pursued by our audience. So we hope that the discussion help the audience gain a clear understanding of how this system works, from their architecture to the ways they communicate and collaborate. The key takeaway is that flexibility, proper organization, and effective communication are the pillars of any successful multi-agent system.
So fine. So thank you all of you for joining us today. If you have enjoyed the episode, so needless to say, please subscribe, share with your friends, colleagues, send us your feedback, um,
Yeah,
and
yeah, yeah. We,
comment.
yeah, yeah.
Comment as much as possible. If you have any issues, any doubts, drop us a message. We'll try to reply. Not in real time, because we are not uh, part of agentic framework. We are humans, so we will reply at ease, but we'll try to reply. And we would love to get some feedback, so that we can improve further. So
Yeah, Rahul. So exactly, like audience, please comment on the episode, what you learned, what you want more improvement, and what are the key area which you feel that it is better if we can explain further. So these kind of comments can open us also to create more effective and more accurate video for your requirement. I also want to just put one information here that we have given some challenge in last episode. We extended that challenge date until next week. So if you are not able to do as of now, you have one more week. Please go and take that challenge. In this episode, we are not going to give any challenge. And I hope that you people will finish first the last episode challenge, and your comment will uh, help us to either in terms of improvement or in terms of appreciation of your effort in the next video. All right. So yes, exactly. And Rahul, I definitely want to thank you for so encouraging and so much valuable insight you have shared once again in this episode. All right, audience. So if you really enjoyed the episode, please subscribe, share it with your network, and drop us your feedback. Until next time, keep iterating, keep innovating, and let your workflow evolve.